Okay, I've been asked to talk or give an example on how to find intercepts, and so I decided to start with a linear example. So the thing that makes this different than probably any algebra class that you've had is you have to understand context. And so just doing the calculations is not going to be enough. You really have to know what those calculations actually found for you. So one of the first things I really encourage you guys to do is to start talking about what do all the letters in the problem mean? So we've got this example. The population of Pine Bluff is modeled by the equation P of t equals negative 7t plus 6,791, where t represents years since 1980. Find the intercepts and explain their meanings in the context of the problem. So before you actually get to the intercepts, let's talk for a moment about what is it that all the letters represent. And so we've got pretty much two letters going on. We've got T, and T represents, it says right here, represents years since 1980. So years since 1980. And what does that actually mean? Well, it's a shorthand way. It's a shorthand way of actually figuring up years. Instead of putting in the year 1980 and have a big nasty calculation, they like simplifying things down. And so what it means is when t equals 1, then that represents the year 1981. And when t equals 5, that represents the year 1985. So if I did t equals 15, that would be the year 1995. So pretty much we're going to take whatever's here, we're going to add 1980 to it to get the year that it's referring to. Okay, then the other thing it has in this equation is this P of t. P of t is one big notation, and what does P of t represent? Well, it represents the population of Pine Bluff at any given year. Okay, so we tend to think of intercepts as x and y intercept. And so we need to figure out, we don't have an x and y anymore, so which one of these is kind of our x value and which one of these is our y value? Well, the thing inside this parenthesis is going to be our x value. So that means our t is going to be our x value. And our P of t, remember this is a fancy way of saying y, so that's our y value. Okay, so now that we've kind of unboxed that for a little bit, knowing what the t represents and the t, we normally think of t as an x value, and that what we normally think of as y is our P of t. Okay, so let's go ahead and find our intercepts now. Let's find our y-intercept first because it tends to be easier. So in order to find our y-intercept, normally we would say set x equal to 0, but we don't have an x. So what are we going to do? Well, we go back and we said, well, the x value that we have is actually a t. So really what we need to do is we need to set t equal to 0. So if we go to our equation, I'm just going to rewrite it here, negative 7t plus 6,791. And anywhere that I see a t in here, there's a t, there's a t, I'm going to plug in a 0. So P of 0 is negative 7 times 0 plus 6,791. Well, anything times 0 is just 0. And when you add 0 to anything, that simplifies down to just the 6,791. Okay, so now we have this. And again, I said, what does it mean? We're going to talk about a lot of knowing the numbers or solving out the calculation is not going to be enough. Now we have to know what it means. Well, we set this up by setting my t equal to 0. What does t represent? T represents the years since 1980. So if no years have passed since 1980, then that is talking about the year 1980. So this would mean that in 1980, what did the P represent? P represent population. So in 1980, the population is 6,791 people. Okay. So that's y-intercept. Now let's talk about x-intercept. Let me move this up a little bit. We'll go green. X-intercept. So for x-intercept, we set y equal to 0. But again, our problem didn't include a y. So what was it that we said was a y? We said that this notation p of t represented the y, so we're going to change that p of t into y. So let me rewrite this again, just cause. So now, since our p of t equals 0, I have to take this entire, got it? I have to take this entire p of t and change it, okay. You have to take this entire p of t and turn it into a 0. Okay, now this won't simplify out. This won't simplify out. We're going to need to actually solve it. So we're trying to get the t by itself. So the first thing we're going to do is subtract the 6,791. What you do on one side, you have to do the other. Minus 7t. And then right now, this is 7 times t. And so the opposite of timesing is dividing. So I'm going to divide by 7, negative 7. And then I'm going to go to my handy dandy calculator. I plug that into my calculator. And so 6791 divided by 7. And I've got 970.14 and stuff. So, okay, that's good, but what does that mean? Remember, this represents years since 1980. So, how many years have passed since 1980? 970 years have passed. So, if we take 980 plus our 970 years, that gets me, calculator, 1980 plus 970, that gets me the year 2950. So sometime way, way in the future. So in the year 2950, what happens? Well, okay, that gave me the year 2950. How did we get this? We got this by setting my p of t equal to 0. What did p of t represent? That represented population. Population. And we set the population equal to 0. So in year 2950, the population will be 0. The population will be 0. So hopefully that helps. That gives you an overview of how to find the intercepts, and more importantly, talking about going back and what do those intercepts mean. And next example will be with a quadratic.